In this video, we're going to talk about some of the vocabulary necessary for graphing trigonometric functions. So some of that important vocabulary is the one thing that's going to help us be able to actually do those graphs and to write those equations. So the first vocabulary word is amplitude. Amplitude has to do with height from the midline. And I'll show you the midline when I put a graph up. The other way we can figure it out is using the formula 1/2 the maximum minus the minimum. And both of those ideas will give me amplitude. The second word we use is the word cycle. Because sine and cosine repeat forever, cycle is one repetition. And again, I'll point that out when we look at the graph. Third word we need to be aware of, and it's kind of tied to cycle, is the word period. Period is the horizontal length of one cycle. So what's happening as we go this direction? Frequency. Frequency is the number of periods in 2 pi, which is the same, remember, from unit circle as 360 degrees. Those get a little confusing, but we'll continue to practice with them. We need to talk about domain. Domain is easy for sine and cosine. Domain is always negative infinity is less than or equal to x, which is less than or equal to positive infinity. Because these graphs never end, they always go from negative to positive infinity. Again, that makes it a little easier to understand. And finally, the idea of range. Range has to do with vertical values. So it's going to be a minimum value is less than or equal to y, which is less than or equal to a maximum value. So that takes care of the vocabulary that we're going to be working with for this unit. Now, just looking at the basic graphs, if y is equal to the sine of x, and we go ahead and throw a graph in here like this, I'm going to put this in terms of radians and degrees for right now. So remember, 2 pi is 360, pi is 180, pi over 2 is 90, and 3 pi over 2 is 270. The sine graph always begins at 0, 0. It reaches a high at 90 degrees, comes back to the x-axis at pi, reaches its minimum at 3 pi over 2, and then comes back again to that x-axis. So as a curve, this is one cycle for sine. Okay? Using some of that vocabulary, make sure that I can see that. Okay, so using some of that vocabulary, it has an amplitude that is equal to 1. Right here, this x-axis That's the midline. From the midline, it goes up 1. From the midline, it goes down 1. So its amplitude is 1. It's 1, we said it has 1 cycle, and that cycle is equal to 2 pi, or 360 degrees. Its period is 2 pi. That's its horizontal length for 1 cycle. Its frequency is 1 because it makes this cycle once within 2 pi. And the range, it has a low at -1, and it has a high or a maximum at +1. Then we want to take a look at what goes on with cosine. So if y equals cosine x, and this is where you're going to need to be careful. When these graphs go on continuously, it can be confusing to know which one is which, and that's when it's important to remember that sine always started here. Cosine is going to be a little different, and that will be the point you're always looking for. I'm just going to do this one in radians. Cosine starts at 1. So again, sine started here, cosine starts here, and that's going to be a lot of times the only clue you have of knowing which graph you're working with. So cosine will cross the axis at pi/2. It gets its minimum at pi, comes back to the x-axis, and then comes back up to a height of 1. So it kind of makes, it's a little sloppy, but it kind of makes a U shape as it goes through what it needs. So where the sine was kind of a sideways S, cosine, you kind of call it a sideways C. That might be stretching it just a little bit. Again, it has a cycle of 2 pi. It has a period of 2 pi. It has a midline, again, in this case the x-axis. Its amplitude, again, it has a height of 1. It has a minimum of -1, so from its midline, its amplitude is 1. Its frequency is 1. And its range, -1, less than or equal to y, less than or equal to 1. So just for a second here, looking at both graphs together, you can see that they are different, but if you were to continue this going on and on and on, you can see where that piece there looks a lot like this piece here, and so it's very important to remember where their starting points are, and that will help you with this graphing.